The Lockheed Constellation was one of the most important aircraft in rebuilding of the airline industry after the war. Often described as the Queen of the Skies, it was the most powerful and advanced airliner of its time. A combination of many technical innovations came together in a true success story. In addition, the distinctive curves of the fuselage and the perfect balance of the design made the plane a thing of beauty and grace. Large four-engine transports are not always aesthetic, but the Connie's lines demand admiration. The Constellation was the pinnacle of piston engine transport design and broke new ground in both civil and military variants. However, its career overlapped into the jet age, and the appearance of new technology brought down a premature curtain on its lifespan. The Lockheed Company, with a heritage stretching back to 1913, had painstakingly built up a reputation for constructing excellent and trustworthy passenger aircraft. Commencing with the Vega and following up with the Orion, Lockheed's reputation blossomed. They became associates with the famous names of aviation between the world wars. Wiley Post and Amelia Earhart both flew Lockheed aircraft. The second list of records set in Lockheed's planes grew rapidly. The company products were not simply a successful reworking of the day's technology, they were innovative and influential. Lockheed had a succession of talented designers. Jack Northrop was followed by Gerald Voltee. When both of these men had gone off to found their own companies, Lockheed retained the services of a team led by the greatest engineering double act in aircraft history, Paul Hibbard and Kelly Johnson. Lockheed developed an excellent family of fast twin-engine transports in the Electras and the Lodestar, carrying between 10 to 14 passengers and what was comparatively only moderate discomfort. In 1938, Howard Hughes piloted a Super Electra around the Northern Hemisphere in just over 3 days and 19 hours. Hughes' respect for Lockheed was cemented, and later he turned to the company into trying to fulfill his aviation ambitions. The flight, of over 14,700 miles, confirmed a view held by many, including Hughes, that civilian airliners would be the mass transit method for the future. And to do this, the individual plane would need to carry many more people over much longer range. Lockheed had already been working towards this with their Model 44 Excalibur. Designed to carry 36 passengers, they were more than receptive when Hughes approached them on behalf of his airline, TWA. His basic specification was an aircraft that would fly a payload of 6,000 pounds from New York to Los Angeles, non-stop, in 8 to 9 hours. He would be a 4-engined, pressurized, luxury airliner cruising at around 300 miles an hour. TWA had set the parameters for capacity and performance, but it was the Lockheed team which designed and built the plane. It drew on many successful elements of their earlier studies. The wing was expanded from that of the P-38 Lightning fighter. The triple tail, originally designed by the Douglas Company, had been tested in the Model 44 project. Kelly Johnson was intimately concerned with the new project. Here in the wind tunnel, cameras catch him changing the shockboard in one of the long series of model developments. Because the plane drew so much on the work done for the Model 44, it was initially referred to as the Excalibur. However, it acquired a new number, the Model 49, and soon was given a new name as well, the Constellation. Lockheed's main rivals had been leapfrogging each other in airline development, with Douglas reaping the majority of the awards in America along the way. However, they did not have a client with the determination and checkbook of Howard Hughes to support them, and their designs were transitional rather than attempting one giant step. Lockheed had conducted a lot of relevant research and development during the 30s, and this had equipped it well to approach the new design. The company had been involved in pressurization experiments with the Army, and Electra had been modified for the tests and given the Army designation of XC-35. The plane first flew on the 7th of May, 1937. With the information derived from these tests, Lockheed were able to devise the Constellation system. This maintained cabin pressure at ground level up to 9,000 feet and restricted pressure to that of 8,000 feet when the plane was at 20. The XC-35 was, in effect, a practical advantage that Lockheed held over their rivals. In a similar way, a lot of expensive development of the wing shape had already been born in the design of the Lightning. Even with these advantages, the cost per constellation quoted to Howard Hughes was, for the day, astronomical. Hughes' determination funded the development from its first meetings with the company in June 1939. However, its progress was slow. Many design problems needed to be overcome in reaching the stage where production would commence. Perhaps because the company had not built such a big aircraft before, Lockheed's team were very flexible about their approach. The series of decisions that set the Connie shape serves as an example. Large engines working at low revs were less likely to feel stressed and break down. So, a combination of such engines with large propellers were suggested. The large propellers demanded absurd ground clearance and very long forward undercarriage. To shorten that wheel strut, the nose is bent down. The large area of disturbance from the propellers suggests the triple tail will not work in flight. However, a more efficient single tail will not fit into a hangar. The solution? Curve the fuselage upwards and take the triple tail out of the propeller turbulence. The plane that results has a straightened S for a centerline in the side view of the fuselage. And it works. As a bonus, it's also beautiful. The first Constellation went not to our Hughes airline, but to the United States Army Air Force. War had swept up the US, and civil aircraft production had become another arm of the war effort. Wartime pressures delayed the Constellation further, but eventually, on January 9, 1943, Project 49 took to the air for the first time. The first plane was the production prototype. There was no transitional model. Existing commercial orders had been drafted even before the US entry into the war, and by 1942, the Army added orders for 300 of the type, most with a more powerful engine. Now being military aircraft, the first Constellations were given a military number. They became C-69s. The test series was delayed due to the trouble with the engines and the first plane was not handed over to the U.S. Army Air Force until July the 29th, 1943. In the time the plane was grounded, Lockheed and TWA took the opportunity to repaint it and do some publicity shots. Some of the testing was also conducted in TWA livery and was used for publicity. This was nothing compared to the publicity coup pulled off by Howard Hughes with the second machine. The plane had been delayed in production and made its first flight only in 1944. It was accepted by TWA on behalf of the military on April the 16th, painted in TWA's colors, though showing its military serial number. The following day, the plane took off with Hughes himself at the controls. It flew non-stop from Burbank to Washington, a distance of 2,300 miles and a record time of 6 hours and 57 minutes. This was an average speed of 330 miles an hour, a respectable speed for a fighter of that era. In addition to the successful publicity for Hughes and the TWA, the event spotlighted the Constellation to the mutual delight of Lockheed and the Army. After the record flight, the plane was kept in Washington for a week of displays and inspections before being delivered to the Army. Over the next 18 months, the C-69s were to make a number of significant long-distance flights and set a series of records. These included excessive transatlantic records, reducing flight time to Paris to under 10 hours. It was evident that the Army had found in the Constellation a valuable personnel transport. The C-69 could carry up to 64 fully armed troops, or alternatively, was capable of transporting a light tank or other medium vehicles. The underworked big engines returned excellent fuel consumption figures and combined with the plane's range, speed, and capacity to put the Constellation far ahead of its competitors. While this was not that relevant in 1945, it would be a telling advantage for Lockheed at war's end. Even though there was a clear need for cargo planes, the Army never placed a high priority on Constellation construction. Under Army direction, Lockheed concentrated on production of other warplanes. In addition to its own Hudson and Lightning designs, the company was heavily involved in construction of Boeing's B-17. Most of Lockheed's experience with four-engine planes during the war was with the Fortress rather than with the non-belligerent Connies. Lockheed produced many thousands of aircraft during the war, but only 22 of them would be C-69s. Army orders for hundreds of C-69s were never fulfilled. Only 15 had been delivered when the war ended, with another 7 planes almost completed. In addition to Lockheed's production being directed to other types, the Constellation used the same engines as the B-29 Superfortress, and few of the power plants were allocated to the program. The engines had teething problems, and the shortage curtailed production. Testing was disrupted with frequent groundings of all types using them. At war's end, 12 of the 15 planes delivered to the Army were declared redundant. All military orders were cancelled, and Lockheed paused to consider their options. The decision was made to go ahead with the Constellation as the company's primary product. In the anticipated post-war expansion of commercial travel, while their competitors tried to rebuild bombers into airlines or upgrade their pre-war designs, Lockheed were ideally positioned with a tested and proven aircraft that was very advanced in comparison to any other type available. By buying back C-69s from the Air Force, including those partially built at the factory, Lockheed were able to offer customer airlines new aircraft almost at war's end, Pan Am were the first to receive these refurbished Army planes, and the Connie made its first commercial flight on the 3rd of February 1946. 3 days later, TWA introduced its Constellation service, first on the transatlantic route, and then a month later commencing transcontinental flights in the US. Competing carriers were mostly relying on DC-4s, and the Connie had no problems outperforming the older Douglas plane. The efficiency of the Constellation was undeniable, and within 2 years, TWA's rivals on the transatlantic route had been forced to change to the Lockheed plane themselves. In effect, the Lockheed decision gave them an 18-month lead over their competitors at Boeing, Douglas, and Republic. This was clear to the airline operators as well. Within a week of the war's end, the company had orders from 8 airlines for over 100 Constellations. The contracts total over $75 million and allowed Lockheed to retain its skilled workforce as production of the Connies was stepped up. The original batch of ex-military planes was soon used up, and new examples started to roll from the factory. Though intended for civil use, they were still the basic C-69 as ordered for the Army. The plane had reverted from its military designation to the Lockheed project number. Thus, the basic aircraft was referred to as the Model 49. During the war, Lockheed had advanced 5 further studies for improved Constellation variants, and these were given an extra numeral, the first being the Model 149, second 249, and so on. One of these projects have been for a long-range bomber variant of the plane, but the other 4 were all transport versions, 3 being improved civilian airliners. There were 73 civil Model 49s, including the recycled C-69s. Their immediate availability after the war gave Lockheed the time to refine the Connie further, before releasing the first truly civilized version. For some carriers, the purchase of Constellations propelled them into the big league. KLM was one. As early as November 1946, they had transferred their transatlantic route to Lockheed Model 49s, and the Connies served the airline well from then to the mid-50s. By that time, KLM was a major world airline, with a massively expanded network of routes. Work on what was to be the first civilian production model had begun in May 1945. This was the Model 649, developed in conjunction with Eastern Airlines. Among the many developments introduced with this model was the SpeedPack external cargo bay. This was another example of Lockheed's team lateral thinking. A Connie offered little cargo space when laid out for maximum passenger carriage, but had the power to spare. To avoid cutting back on the number of passengers, additional cargo space was bolted to the outside of the plane. This increased the goods carriage by 8,000 pounds, at a penalty of only 10 miles an hour in speed. The model also introduced a new and more powerful version of the engine, rated up to 2,500 horsepower. The 649 first flew on October the 18th, 1946. It was a notable advantage on the Model 49 in many aspects. Major improvements have been made to soundproofing and cabin air conditioning, giving a far more pleasant ride than any other airliner at the time. Easton began to advertise their planes as their gold-plate Connies. They began operating services in May 1947. Overlapping with the deliveries of the Easton 649 came another new version, the 749. This had been developed as a long-range model for overseas operation, based closely on the Eastern aircraft. The outer wings contain additional fuel tanks, which added a further 1,000 miles to the range of the plane. With this version, the New York to Paris route could be flown non-stop. Further improvements to the 749 were recognized with the sub-designation 749A. Air India was the first to employ these, bringing them into service beside the earlier Connies then purchased. The improvements made to this version were directed to obtaining a higher gross takeoff weight, bringing an additional nearly 5,000 pounds to the payload. The weight of the Connie had grown markedly during her career to that time. The initial C-69 had a maximum weight of 72,000 pounds, but this had been expanded to 107,000 pounds with the 749A. At the same time, the range had been increased from 2,400 miles to well over 3,000. Many of the improvements made to these planes were later built into earlier models, blurring the distinctions between the earlier versions. The Constellation stood at what was to be the pinnacle of propeller-driven airliners. The technology of propellers themselves was very highly advanced. With its fully reversing blades, the Connie could pull itself up on landing in a very short time, or could back itself into a parking bay. The props could also be fully feathered to reduce drag if an engine cut out. Extreme use of the reversing props on landing produced this sort of spectacle, with the Constellation not only coming to a halt in a very short strip, but promptly backing up. The Connie's props then carefully matched to the huge engine chosen for the plane. The big blades caused some problems with the undercarriage in hoisting the plane clear of the ground, but these problems were offset by the advantages gained in flight. The big engines were run at very low revs, with no stress and minimum fuel consumption. They were quite capable of keeping the big plane aloft, even if two were cut out, and even if both of the engines on one side had to be shut down. By settling the plane to demand so little of its power plants in normal operation, Lockheed built in an enormous reserve. The 749, a specification had originally delivered from the renewed military interest. The original C-69s had been a problem aircraft for the Army, due in no small part to the experimental nature of design. The Army was well served by its large fleet of Douglas DC-4-derived C-54s, and abandoned the Lockheed plane. But when in 1948 the new U.S. Air Force turned its attention to the Connie, it was no longer a new design that pushed the state-of-the-art under wartime handicaps. This time, the Air Force bought a minor variant of the well-proven airliner as a C-121A. Two were immediately redesignated as VIP aircraft and allocated to General MacArthur, who transferred the name of his old C-54 Bataan, and General Eisenhower, whose plane was known as Columbine. Later, VIP Connies were assigned to Eisenhower after he became president and were named Columbine II and Columbine III. The non-VIP C-121As were used as cargo and personnel transports, and had strengthened floors and large rear fuselage cargo doors. Over the next few years, the original Air Force order of 10 aircraft were all reconfigured as VIP planes. The first was delivered in December 1948, and the last in March 1949. They soldiered on for nearly 20 years of service and were not retired until the late 1960s. The return of the Constellation to Air Force service was followed by interest from the Navy, and a new military role dawned for the plane. The C-121's career was to be very long and very influential, and redefine the military uses like transport aircraft. By the time of the Columbine III, President Eisenhower's plane was a much different proposition from his first Constellation. In the development of this new type, the story of the Constellation returned to its beginning, to the first C-69 built. This had displayed its military number 310309. However, its company number had been 1961, and it was as old as 1961 that it was to gain its individual fame. During the war, the first Constellation had served its share of Army duty. During this period, it was re-engined with Pratt & Whitney radials as an emergency-driven response to the chronic problems with the Wright double cyclone engines. After this refurbishing, the Army took to calling it the XC-69E, though it was otherwise unchanged. At the end of the hostilities, it was then put up for sale and bought by none other than Howard Hughes. In 1949, he sold it back to Lockheed and a transformation began, as it was turned to the prototype for the Model 1049. The most obvious change was that the plane was stretched, and two new sections of fuselage were built into it. One section before the wing added 10 feet and 9 inches, and the second behind the wing 7 feet and 8 inches. The alteration was so radical that the company marketed the plane under a new name, the Super Constellation. TWA had again been involved in the development of the plane, but Eastern Airlines had lodged its actual order first, and so they received the first Super Connies. In addition to the obvious lengthening, there were many other improvements. A better de-icing system for the wings, stiffed wing surfaces, increased fuel capacity, and more powerful engines were all incorporated. The gross takeoff weight of the plane increased by only 12%, but such was the efficiency of the design that the payload increased by 40%. Seating was available to cater for between 69 and 109 passengers, as the Lockheed devised a variety of layouts. Some were designed for long-range carriers and others for commuter airlines. Other plans with fewer seats catered for routes with a higher proportion of freight, or allowed for the removal of fitting to use the aircraft as a part-time cargo plane when passenger traffic was light. The company's intent was clear. The Constellation had given them a captive market they did not want to lose. The new planes were assembled in Lockheed's appropriately named Hall of Giants. The first version had only a limited lifetime. It had been intended to give a new and revolutionary turbo-compounded engine, but teething problems with the new power plant that led to the use of standard, though uprated radials. The 2,700 horsepower delivered by these engines left a Constellation slower than its rival, the Douglas DC-6, and only 24 were built. Lockheed were forced to persist with the introduction of the more powerful but underdeveloped new engines. Though problems persisted, the strategy paid off and sales picked up. With the introduction of the new engines, the plane received a further 20% boost in its weight-to-range ratio. All comparisons with the opposition were addressed, and all orders resumed their earlier, partingly busy frequency. This beneficial change was in part forced on the company. They had had enough of unproven engines earlier in the Constellation's career. However, the military were very interested in an uprated Super Connie, and much less so in the underpowered original model. Not only did the re-engineering rekindle civilian sales, but the new Super Constellations were to be the testbed for a revolution in military aviation. Today, the concept of aerial command posts, electronic surveillance centers, and radar stations is commonplace. They've proved their worth in time, and again, during their short career. Most of the experimentation that proved their effectiveness was conducted in Constellations, as was most of their early service. Again, old 1961 was involved in making aviation history. As with domes above and below, the original plane was used to trial the installations. The first Connies constructed as airborne radar pickets were built for the Navy. They replaced the earlier rudimentary installations aboard converted World War II bombers. Aboard the planes, a crew of 22 were involved with aircrew, radar operations, and engineers. With their long range coupled to the search range of the extensive load of equipment, these Navy WV-1s proved the worth of the concept and installed it as an accepted part of naval practice. Soon, the idea spread to the Air Force. The Air Force had placed orders for Super Connies for conventional use as transports, but C-121s would not be delivered as such until 1956. Before any transports could be built, the Air Force acknowledged their better use as an airborne early warning aircraft and changed the order for the first 10 to its own flying radar pickets as RC-121Cs. These planes are loaded with 15,000 pounds of radar equipment, with crews at 335 miles an hour up for 24 hours on patrol. The RC-121C was similar to early Navy Super Connies, with their height-finding radar housed in the 8-foot-tall hump, and the bearing scanner located in the ventral dome. The RC-121Cs entered service in 1953 and were mostly employed in patrolling the western seaboard of the USA. They were followed in 1954 by the first of an order for 72 RC-121D Warning Star aircraft. In addition to the passive role of detection, these incorporated offensive activity as the control centers for the guidance of fighter interceptors. From the basis of the Morning Star, a number of options presented themselves. Once, the idea of putting equipment into aircraft was suggested. There was a rush of ideas about which equipment might be suited for the treatment. Advanced electronics and surveillance types multiplied. As the transport planes appeared, they were often pulled back to the factory for refit as one or another of the electronics versions. The appetite of services for these valuable aircraft was insatiable. Over 220 of the main types alone were built, disregarding the one-offs and the small runs. Most of these planes were also completely re-equipped at least once in their lifetime. Between the Air Force and the Navy, over 25 different designations were used to identify versions of the radar-equipped Connies and their control center brethren. In addition to proving the concept and paving the way to their success, these constellations also performed very real service in an era when there was no other practical solution. At the height of the Cold War, when hostility and distrust often combined in equal degree to foreign policy, a calmer picture of reality was maintained by these electronic eyes in the sky. In 1962, the RC designation was changed to EC, and the electronic Connies were to earn their later Vietnam fame under that designation. They were a pivotal factor in the US defensive strategy, and had become as important as the cargo-carrying versions that were dispensable. Despite using non-standard fuel and requiring piston engine maintenance that was in almost dead arc form, the Connies were nursed along. Old age and technological redundancy could not undermine their essential functions, and some were to remain in service until the early 1980s. Their longevity was helped not only by their experts' care, but by the excellence of their original design and construction. The jet age was, however, drawing in on the Constellation's career. It was obvious that the introduction of the jet airliners would change the whole market expectation, and Lockheed were determined not to be left behind. Aware of the limitations of early jet technology, they set about refining a system of compound engines, or jet props, using jet engines to drive propellers. They had already extended the piston engine by the use of turbines driven by the exhausts. These had added 20% more power to the engines, and with the peak of the piston engine development, employing a jet and prop combination was designed to extract maximum economical efficiency from both technologies. Once again, the testbed for aviation milestone was old 1961. In its last major notable achievement, the venerable airframe was fitted with an Allison turboprop in the outboard-starboard position. This engine couldn't save the Connie, but it was part of the foundation of one of Lockheed's most successful aircraft, the C-130 Hercules. It was also at the heart of the successful Lockheed Electra, which kept the company alive in the civilian market. However, for the Constellation, its success as the pinnacle of piston engine airliners somehow acted against anyone taking a jet-powered version seriously, even though the finest development, the Starliner, was yet to come. With a new wing shape and other major revisions, the Starliner carried Lockheed's hopes of continued dominance of the long-range airliner market. However, though orders for Super Connies didn't dry up immediately, there was no flood of orders for the new plane. Only 44 of the vastly improved version were built, phased out of service relatively quickly, being replaced by jets. The improvements made to the Starliner were numerous, and it was undoubtedly the finest piston engine airliner of all time, but it was too late. Lockheed's enterprise imagination and innovation continued to work around the Constellation, and several refinements, including the now familiar revolving antenna, were developed and tested with Connies. The new development of the Starliner gave Lockheed a proposal to put the Air Force, and the company invested considerable time and money sorting out the best package it could develop around the plane. The revolving dish was only one of the systems developed for the submission. With turboprops, extended range, specialized layouts, and a large number of new features and improvements, the Starliner was being prepared for what would be the next sales opportunity. By then, the success of the airborne radar and control planes that the fleet of such an aircraft be maintained. The aging C-121s would need a replacement. By the time the competition was announced, Lockheed knew that no matter how excellent their proposal was, they didn't really stand a chance. Hot on the heels of the formal call for tenders came the specifications, and these confirmed Lockheed's fears. Time had stolen a march on the military Starliner as well as the civilian version. The Air Force was not just in the market for a replacement, but for their constellations to be more precise. They were in the market for a jet-powered plane. The Boeing company had the world's best such aircraft on its catalog. Developed for the Air Force as a jet tanker, the KC-135, the result of a foregone conclusion. However, the appearance of the replacement did not signal the end of the Connie's military career. Whereas the arrival of Boeing's jet had seen the quick demise of civilian constellations, the Air Force and Navy were content with the capabilities of the plane. And coincidentally, they had need of them. The U.S. Air Force C-121s, to be based in the Asian theater, arrived in Thailand in April 1965. Although Navy planes had been the first Connies involved, starting with the missions in August 1964 at the time of the Gulf of Tonkin incident, the Constellations flew throughout the war and their service was invaluable. They performed in a number of functions, some of which were developed and tested as a response to the armed combat raging below and in the air around them. The big plane's commodious fuselages saw many refits. The variety of constellations deployed to Vietnam illustrates the way the big planes had taken on so many roles for the services. Their main work was as an airborne early warning aircraft, but they were also used for a number of other missions. A few cargo versions were used primarily for aeromedical evacuation and as passenger planes. However, beyond that, the specialist electronic planes filled a number of roles. One of these was the relay of data from sensors scattered along the North Vietnamese supply routes as a part of Operation Igloo White. To have diverted the jets to these tasks when they were needed as refueling tankers would have been highly impractical, and the Connies, available and reliable, soldiered on. The Constellation's original deployment to Vietnam was essentially defensive. They were to be used to provide a radar picket to guard against North Vietnamese bombers attacking targets in the south. However, this proved to be a short-lived need, and the duties that kept them in the theater were over a broad spectrum. One of the most unusual roles the Connie was called on to perform fell to this plane, and in C-121J of the Navy's Development Squadron, PX-8. The designation was given to a group of planes that were variously modified to secret specifications. There was no conformity within the designation. It was effectively a grab bag for various one-off Connie versions. This plane, for example, had its own special fit and its own special mission. The equipment fitted to this plane was definitely non-standard in military terms. These 2-inch tape players were the ultimate in professional television formats at the time. The duty of the aircraft was to serve as television and radio broadcaster for the armed services networks. By hauling the transmission aloft, the service was taken out of range of the ETCON interference. Ground-based transmissions would have required infrastructure which, as a tempting target, would have needed constant guard. The quietly plotting Constellation transmitting from on high made the maintenance of the service broadcasts practical. Of course, most of the Constellation activity in Vietnam was far more actively involved in the conflict, with most of the important work being performed in monitoring the North Vietnamese. As soon as the operations over the North began, the Constellations became essential factors in the struggle. As the war went on, their role gradually evolved from passive to active involvement. Operating over their own ground, the North Vietnamese MiGs were given very accurate information about the whereabouts of U.S. aircraft in their airspace. This advantage was at first simply countered by the operations of the U.S. radar planes, which were able to relay similar information about MiG activity to the American strike aircraft. As the war went on, the Connies increasingly assumed a more active role, making direct contact with American fighters and guiding them in attack on any North Vietnamese activity. When the North became better equipped with missiles, the Connies were able to fix the location of any SAM site radars that were operating. This served two purposes. It warned the aircraft in the area to expect trouble, and it led the Iron Hand Weasels to attack the sites. The last Constellation operations in the theater were flown in May of 1974. Well after the last operational strikes by the U.S. forces, the big observers continued their monitoring. By then, it was 25 years after the first electronics refitted Connie, and so impressed the Navy. It was also 31 years after the first Constellation flight. When the Constellation was at its peak, the axe fell. They were forcibly retired from service long before they wore out. The major airlines were forced, partially for reasons of prestige, to abandon props. The Connies have been the key to the establishment of long-distance civil traffic after the war, but business has no place for soft sentiment, and they were abandoned quickly. By the early 60s, the civil career of the Constellation had moved to small airlines and lesser routes. There, they continued to work for many years. Gradually, they become relegated to cargo, and then lingered further as isolated crop dusters and fire tankers. The military career lasted much longer, with the last Navy Constellation being retired in June 1982. The last Constellation built had been delivered in 1958. 856 Connies were made in 16 years of production. Their career stretches from World War II to the Space Shuttle. They were, throughout their career, used as testbeds for a multitude of developments. The results of this service are still seen in use in both military and civil aviation today. One of the most beautiful aircraft ever produced, time reduced their worth to weight in metal. Very few escaped the scrap merchants, and now they're treasured museum pieces.
Hello. This is to be a movie about flying, one of my very favorite subjects. In fact, there's nothing I'd rather talk about, especially during this 50th anniversary year of powered flight. Of course, I like to talk about radio and television, too. They've been mighty good to this country, boy. This is the way I make my living. But what makes that living worthwhile is to get out there in the wild blue yonder in a good airplane with the whole universe waiting for me. Not just because it's a thrill, although it certainly is that, but because I like to think that aviation, as far as it has advanced, and it certainly has come a long way, is still very young. Oh, we've come a long way since the days when my good friend, the ace of aces, Captain Eddie Rickenbacker, used to fly around in France in those Spads. The Dean of Aviation. Just think, he's been flying for nearly 40 years. Why, it's only 50 years since the Wright brothers. You know, they call me one of the old-timers in aviation, but I didn't begin to fly in earnest until 1929. Gosh, that's almost 25 years ago now, isn't it? But you know, I've done more flying in the last 3 years than I did in the first 22. Here, let me show you. I have been commissioned in the Naval Reserve since 1939, but because of an old injury to my legs, the Bureau of Medicine and Surgery wouldn't clear me for military airplane flying until 1950. So it was in 1950, in September, that I got my Navy wings at Pensacola, the happiest day of my life. Since that time, I have qualified as a carrier pilot, as a jet pilot, as a helicopter pilot, and here is the coveted Navy green ticket, the highest instrument rating given to Navy pilots. Of course, I'm very proud of all of these military certificates. But here's one here that makes me very, very, very happy. This is the certificate that Captain Eddie Rickenbacker gave me recently, making me an honorary captain in Eastern Airlines. As I was saying, planes have come a long way in the last 50 years. Here's one very much like the one that the Wright brothers used. Used to make 40 to 50 miles an hour. There's still one or two of these around, too. It's a funny-looking affair, but most of the basic principles we use today were developed in this plane. It didn't fly high, and it didn't fly far, but by golly, it flew. Looks kind of like an overgrown box kite, doesn't it? Well, you can take it from me, it feels like one, too, when you're up in it. You've heard the expression, flying by the seat of your pants? Well, this is where it came from. Sitting in this old bucket seat right here. See, the Wright brothers had no instruments of any kind, except a little old oil gauge down here. It tells you got some oil pressure back there. And this stick, the column and this wheel is exactly the same as we have in the big airliners of today. When I push the stick forward, notice that flipper comes down, it pushes the tail up and the nose down. Vice versa this way. Want to drop the right wing, do it this way. Left wing this way. And here are the rudder bars that work the rudders in the tail. You see, the principles were the same then as they are today. No difference. Here is a model of a Spad, the airplane that Captain Eddie Rickenbacker flew in World War I, only 10 or 12 years after the Wright brothers' first flight. It's a shame that it had to be used as a weapon of destruction so soon, but the war brought that on. This is Captain Rickenbacker in the plane he made famous in World War I. These old films show the dashing young skipper of the 94th Squadron leading his boys into a dogfight. The hat and the ring insignia was always present when the fighting was thickest. The wild blue yonder was really wild in those days, when there was just so much wood and canvas between you and the enemy, between you and the ground. Down in flames was the rule rather than the exception. They had no protection. They had no parachutes. Yes, they paid a high price, but it was through Captain Rickenbacker's exploits in World War I that the terrific fighting power in the airplanes was made known to man. This little Spad carried a very powerful engine for those days and often flew up to 135 miles an hour, straight down. There aren't many of them left, but here comes one of those old-timers now. And look who's flying it. It's Captain Eddie, the one and only, Captain Rickenbacker. Hey, wait a minute. I want to get in this scene myself.
Hey,
Captain Eddie. How's it feel to be at the controls of this old baby again?
Well, frankly, it brings back a lot of memories, Arthur. Some good, some not so good, but maybe we had to do it regardless. You know, many a morning I used to sit around up there at 20,000 feet with the sun at my back waiting for the enemy Fokkers to come around.
20,000 feet in that open cockpit?
Right.
Nowadays we got heated and pressurized cabins. Didn't you get cold?
Oh, how? It sure was. In fact, we had to come down to thaw out. You know, it gets so cold up there. Yes, Arthur, it's a wonderful little ship, in spite of the fact that it's made up of wood, and wires, and struts, slack, and tape, pulled together with all of these wonderful combination gadgets. The fact of the matter is, the only metal in it, the engine and the machine guns. Yes, quite a change.
And in 30 years, too.
True, and on the other hand, when you take a look at the beautiful Super Constellation, all metal. One end to the other, aluminum, steel, brass, copper, in fact, every kind of metal known to science is involved in its structure.
Just take a look at that Super Constellation, folks. 114 feet long, with a wingspan of 123 feet. 4 of the latest compounded engines of 3,250 horsepower each. Do you realize how much power that is? Why, each engine has more power than a locomotive. This plane can fly up to around 400 miles an hour. And we are going to take a ride in it. Let's hear what Captain Eddie is saying.
Arthur, one of those wheels weighs almost as much as a Spad. By the way, here comes your crew.
Oh, hello, Dick.
Hi, Dickie boy.
Hiya, Captain.
How are you? Hello, you.
Hello, Captain.
Nice to see
you.
Hello, Captain.
Arthur, we're due out of here 2 o'clock. Just 1 hour from now.
I'm ready.
Well, as long as you fellas are going to do the flying, I might as well go on. Have a good trip. So long, guys.
Thank you,
So
Captain.
long. What a guy. Well, now we're going to take you on a regularly scheduled flight from New York to Miami. Only this time, you're coming up in the cockpit with us. And we're going to show you what goes on behind the scenes. Well, Hugh, how are we fixed?
Okay, sir. I'll see you on board.
Good. Now, folks, I want you to meet my co-captain for today's trip. This is Captain Dick Merrill. Over 25 years with Eastern Airlines. One of the grandest guys and one of the best pilots who ever lived. I'm sure you know of his exploits as well as I do. To name one, he was the first pilot to fly a commercial flight across the Atlantic and return. What do you say, Captain?
I say, Captain, let's check in at crew scheduling and then go look at the weather.
Aye, sir, we'll do it. Oh, boy, look at that beautiful high. Hey, but look at this front back here. See, how fast is that front moving?
About 25 miles per hour to the east, Captain. Here's the latest map.
Good. Thanks, Henry. Dick, let's fly down to 22,000.
Sounds like a good altitude to me, Arthur. I'll go in and make out the flight plan.
Okay. In this room, they get weather reports every hour on the hour from weather stations scattered all over the United States and Canada.
Here you are, sir.
Hi, Dick. Flight 601, proposed 1400.
The dispatcher's office is the central intelligence for all aircraft. They know where every plane is every minute. On this big board, the clerk notes the position of each plane en route, as reported by radio, and the time due at the next checkpoint. We fill out our flight plan with the dispatcher, giving our exact route of flight, the altitude, the amount of fuel, and so forth. A copy of this will be filed with the Government Airways Traffic Control.
Here you are, sir. How does that look to you?
The dispatcher gives us official clearance, and we're on our way.
Everything okay, you?
The ship is ready, sir.
88 passengers, Captain. Gross weight 112,000 pounds.
Another full load, eh? Thanks, Al. That's what I like to see. Now, for you folks who've never been up on a flight deck before, this is it. The captain and the pilot have the flying controls at their fingertips at all times. While over here, the engineer is very busy with the engine instruments. These are the throttles, just like the accelerators on your car, one for each engine. 2, 3, 4. This is the control column. And with it, you fly the airplane. To the right, to the left, down, up, and here are your rudder pedals down below. The airspeed indicator shows just that, how fast we are going through the air. The altimeter tells us how high we are. This vertical speed indicator tells us our rate of climb or descent. The automatic direction finder? Well, that's just what its name would imply. It points to where we want to go when we tune in a radio station with it. This is the flux gate compass. And this one is the old reliable magnetic compass, just like Columbus had when he came over here. This is the omni-range bearing indicator. This is the localizer and glide path indicator, about which we'll talk a little bit more later. This is the artificial horizon. It shows the attitude of our plane with reference to the real horizon. Of course, you know that we have radio contact at all times, ship to ship, ship to ground, 2 or 3 transmitters and receivers. Now, this plane has already been very thoroughly checked by the maintenance department, and during the last hour, it was checked by our own flight engineer. But that's not enough. The pilot and the captain have 1, 2, 3 lists of checks to make before we start down the runway to take off. Okay, Dick, we'll do the before starting engines check, huh?
Right. Oxygen mask.
Immediately available.
Brake selector.
And so on through 39 separate items. Now, you passengers wonder why we sit and wait sometimes at the end of the runway. It is because the captain and the co-pilot and the crew are making these additional last-minute checks. Well, I guess we're ready to wind them up, Dick. Now I'll switch over to intercom and talk to that gentleman outside there by the nose and get ready to start the engines.
Ground to cockpit. Clear to start.
Ready to start. Start 3.
Turning 3. Contact 3. Clear to start 4.
Start 4.
Turning 4.
As soon as the second engine starts, the ground crew checks with the cockpit.
Hydraulic pressure up.
Now the safety pins can be removed from the 3 landing wheels. Otherwise, they could not be retracted when the plane is in the air.
Clear to start 2.
The same routine is followed for each engine.
Clear to start 1.
When the engines are all turning, the cockpit team goes through another checklist routine. Okay, Dick, let's do the before taxiing check.
Flux gate.
Cage.
Hydraulic pressure.
Okay.
Gear pins.
3 pins. After that, he checks by radio with the airport ground control.
Idlewild ground control from Eastern Airlines trip 601. Taxiing instructions.
Eastern 601, clear to taxi, clear to runway 13 right, 13 right, the wind south-southeast 10, altimeter 2997.
Get the runway, Arthur.
13 right, right?
Right.
13 right, okay. Ready to taxi? Brakes off. Ground control having given us permission, we taxi over to the warm-up block. You notice they told us which runway to use and the wind direction. At the warm-up block, we go through the next, or before takeoff check.
Trim tabs.
Set.
Light instruments.
Okay.
Fitted heaters. Off. Mixtures.
11 items are checked this time. The last check before the plane leaves the ground. Ready to check mags. Number 1. Left. Move. Right. Move. Number 4. And so on until all 4 engines have been run up and checked. We are now ready for takeoff clearance.
Idlewild ground control from Eastern 601. Ready for clearance.
Roger, Eastern 601, cleared for takeoff.
All right, brakes off. Clear for takeoff. Okay, here we go.
Ready for takeoff.
Takeoff power.
Takeoff now. Gear up. Gear's coming up.
There you are. See how easily she wanted to get off? Big as this Super Connie is, she wants to fly right on off of there. Veto power.
Veto power.
It's maximum except for takeoff. Flaps up.
Flaps coming up.
Flaps are extensions of the wing area used to give more lift during the slower speeds of takeoffs and landings. They withdraw in flight for greater speed. Climb power.
Climb power.
Here for magazine, sir. Copper mechanic.
Okay, we finish our climb check. Now it's time for a Chesterfield. Dick.
I don't smoke, Arthur.
Hugh,
Okay, thanks.
you get down on the deck, you buy 'em by the carton, see?
Indubitably.
What?
Yeah. Yes, sir.
I thought you wouldn't wrap your tongue around that one twice. Building up his par. Oh boy, this is the life. Hey, there goes that northbound Silver Falcon. That's one of Eastern Airlines' wonderful twin-engine planes. The new type that has superseded the beloved old DC-3. It's the most advanced twin-engine commercial plane in the air today. She carries 40 people at a cruising speed of around 300 miles an hour. One of the most comfortable airplanes you could ever ride in. Eastern uses them to pick up passengers from intermediate points to connect with these big Super Connies. It's a wonderful airplane, that Silver Falcon. Smells like the girls are getting ready to serve dinner back there.
Gwen, the water's hot for tea if anyone cares for anything.
Thank you, Al. Would you like some dinner, sir? How about you, now? What? Oh, this looks delicious.
Okay, let's level off here. Cruise power.
Cruise power.
Now, people often ask me, I can figure out how you do this in good weather and over land, but how do you navigate when you're up over the clouds and over the ocean? Well, honestly, it's so simple, I hate to tell you. Well, for direction, we have the compass, the automatic direction finder, and the Omni range receiver. Let me show you how that works. Dick, take over for a minute, will you? Look, let me show you how it works. I'll fix this up here and draw you a little map. Let's come on down here. We draw the coastline down through Atlantic City, on down here to Wilmington, Myrtle Beach, on down the coast very crudely. We're flying along out here somewhere. We've got an Omni radio station here in Atlantic City. We've got another one here at Norfolk, and we've got another one down here at Myrtle Beach. So we tune in this station here. And on our little dial window I showed you a minute ago, it says that we bear from that station, say 300 degrees. Well, we draw a line of 300 degrees magnetic true bearing right through that station, which extends out here somewhere. We are somewhere along that line, but where? Okay, so we tune in this next station down here. And that one says in the little window that we have got a bearing of, say, 260 degrees. So we draw a line through that station at 260 degrees true. And where those two lines cross, that is where we are, right there. Little snooze, a few hours have gone by, and we are now approaching Miami. Now we'll show you what takes place in our approach and our landing. Time for us to start a gradual descent. But first, we have to get clearance to approach. Richard?
Miami Tower from Eastern 601, 10 miles north.
Eastern 601, 10 miles north at 11. Make left turn in, runway 17, wind south 10, altimeter 2998.
Okay, Dick, let's have about 60% flaps.
Flaps coming 60.
Gear down.
Gears coming down.
Eastern 601, clear to land. 80% flaps.
Flaps coming 80.
Full flap.
Full flaps.
The captain will reverse the pitch of the propellers and push the air forward and just stop the plane. There. You see, that acts as a powerful brake. So next time when you're riding in an airliner and you hear the engines roar soon after you're on the ground, remember that's what he's doing, reversing the props to stop the airplane. Well, here we are, right on schedule. I hope you folks enjoyed this as much as we did. Of course, this was purely and strictly a routine flight with beautiful weather. But maybe we've been able to show you some things you hadn't seen before. But you know, I'll bet you right now some of you are saying, well, sure, this was nice, it was lovely weather, but what happens when the weather is bad? Well, believe me, it's still routine. You see, in the first place, up where these Super Connies do most of the flying, the weather's always nice, way up on top of all the bad weather. Usually it's only on approaches to our airports that weather becomes any problem, and then not much. As long as we have half a mile of visibility and 200 foot of ceiling, no problem at all. Now, these minimums are arbitrarily set up by the Civil Aeronautics Administration in the interest of general safety. Actually, we can land one of these airplanes when the minimums are 00. Let me show you. Here we are flying on instruments. We're in the clouds. It's one of those nights that the birds aren't even walking. We have been cleared to make an instrument approach. We have been cleared to the outer marker. This point we call the outer marker is located approximately 5 miles from the end of the runway. A light flashes on the cockpit panel. At the same time, the ADF needle indicates the passage of the marker, and we also get an audio signal. At this point, the glide path is intercepted. The glide path is a sloping radio beacon down which the aircraft should make its descent to the runway, and is indicated by the horizontal needle. When the needle is centered, the aircraft is on the glide path. If the needle moves above center, the aircraft is low and must climb back to the path. If the needle is below center, we're high on the glide path. This is a big help in itself. But in addition to the ILS, the Instrument Landing System, we have GCA, that is Ground Control Approach, and that can give additional valuable assistance.
Radar monitoring on localizer voice as you approach the outer marker.
By means of this radar, the GCA controller sees the approaching plane as a bit of light moving on his scope and can direct it safely to the airport. When the flight has been directed to the approach course, it is turned over to the radar monitor for final approach.
Radar to eastern, you're approaching the ILS course. Turn to a heading of 247, and I'm turning you over to the radar monitor for final approach. This is radar monitor.
Etched right on the scope is both glide path and localizer, and any deviation can be detected and measured in feet.
You are 4 miles from the end of the runway. 200 feet to the right, of course, but correcting nicely. Your glide path is good. You are 3 miles from the end of the runway. Your course is good. Glide path slightly low, but okay. You are 2 miles from the end of the runway. Your course is good. You're now approaching the middle marker. You're over the middle marker. The approach light should be coming into view.
Approach lights in view. Thank you, GCA. That column of lights ahead shows the approach to the end of the airport runway. Each bar of light is 100 feet apart, and that ball of light traveling away from us at such a high rate of speed is leading us right to the approach end of the runway itself. The green lights mark the start of the runway, and the border lights on each side stretching out into the distance outline a 1.5 miles of airstrip just waiting for us to land on. So you see, it really isn't too difficult. Actually, we use these landing aids every day in good weather and bad to keep in practice. And practically all of the airports that we use are equipped with them. The thing to remember is that it's all figured out. Nothing is guesswork. It's still routine. Now I'm going to show you the most amazing demonstration of power in an airplane you've ever seen. Let's go back upstairs. Now watch this. Feather 1.
Feather 1.
Feather 2.
Feather 2.
Look at that, on 2 engines. Purring along just like a kitten. You haven't seen anything yet. Feather 3.
Feather 3.
Boy, oh boy, look at that. On 1 engine. Going along just as steady as you like. Only a Constellation can do this. Why do we have all that tremendous reserve of power? Because, my friends, power means safety. That's why this Super Constellation is the most dependable airliner in the world today. Okay, Hugh, bring in 1.
Unfeathering 1.
You know, these engines are not only the best that money can buy, but they are maintained by the finest bunch of aviation mechanics in the world, trained for years by Eastern. You know, you can have the best captains and the best pilots in the world. You can't do much good if the engines don't run. We've got the best mechanics in the business in Eastern. Doesn't that inspire confidence? I think it does. Well, we all have our dreams, I guess. I never did aspire to own an airline, but I always wanted an airplane of my own, even when I was a kid. I've got two of them now, a DC-3 and a Navion, and there are thousands of privately owned airplanes all over America today. This is the little airport or landing strip that I use when I fly home to Virginia. That's my Navion coming in there, a single-engine plane. We can go most anywhere in it. It has all the technical facilities and instruments that the big planes have. Besides the Navion, I have a DC-3. That's my Air Force. We call this little field the Leesburg International Cow Pasture. Cows out there give 100-octane milk. Of course, these are reciprocating engines here. We have the regular jet engines like we use in our military aircraft. This is a Lockheed F-94C Starfire. It's an Air Force jet-propelled fighter. You see, these jet engines, contrary to what I'm afraid is too popular a belief, are not the lethal things they're cracked up to be. As a matter of fact, they're so quiet and so vibrationless that to ride behind one of them is a real comfort. We're hoping someday soon that our commercial transports will be jet-propelled. You see, a jet engine has no propeller. The air is drawn in through the intake ducts just forward of the wings, compressed and mixed with burning fuels to produce a powerful jet of exhaust gases, which are expelled aft. The mechanism involved in reality is much simpler. The propeller is replaced by an air compressor. There's a combustion chamber into which we inject fuel to expand the air and increase its velocity. And installed in the path of the exhaust gases is a turbine to drive the compressor. There you have it. This is my friend Tommy Daniels, a member of our Air Forces for 12 years. Tommy is one of the thousands of fine young men who are making a career out of the Air Force, taking advantage of the wonderful training they receive. How do you like it, Tommy?
It couldn't be better, Mr. Godfrey. It's really wonderful.
Now I'm going to have the pleasure of flying with Tommy today in some very exciting scenes. So, Tommy, what are we going to do?
Well, Mr. Godfrey, I'd like to take you through some pull-ups to show you just what this airplane is designed to do in climbing to altitude rapidly. I'm sure you'll enjoy it, but it's just routine flying to us. We do it every day. Now, before we take off, I would like to have your friends take a look at the afterburner in the tail section. It gives this airplane this terrific wallop.
Okay, Tommy, we'll do it. This Lockheed Starfire is an all-weather Air Force interceptor. She was designed especially to get off the ground quickly and climb to altitude very quickly in the hope of being able to intercept and stop any enemy bombers that might come over this way. To help her get up there quickly, she was designed with this afterburner in the tail section, which is why this tail section is so much bigger than any other jet you've probably seen. See, there's an auxiliary engine back in here that uses exhaust gases as they pass through and reburn them with greater efficiency, giving additional thrust to the engine. That really is something to watch. It get off quickly and climb to altitude, boy oh boy. I want to show you what I mean, so we're going to fly by first on the regular jet, and so you can see and hear how it performs. And then we're going to fly by with the afterburner on. And you'll hear, well, you'll see for yourself. You just watch. Okay, Tommy, let her go. We are approaching you now on straight jet. Watch our rate of climb. Now we are approaching with the afterburner in operation. Watch the increase in this climb.
Well, how'd you like it, Mr. Godfrey?
Boy, my pants are where my necktie ought to be. But it was wonderful. Gee, what a dive. Woo!
That's just a sample of what this airplane can do, Mr. Godfrey.
Thank you, Tommy. And this airplane can do much more, as we're going to see.
Yes, and here comes the man now who's going to do it.
And here is the chief test pilot for Lockheed, my good friend Tony Levick.
Hello, Arthur.
It's good to see you.
Well, if you think those pull-ups were something, Arthur, just watch and I'll show you how easy it is to penetrate the sound barrier with this airplane.
I wasn't with Tony on this flight, but we have a camera specially rigged on the tail to give you a close-up view of what happens when you break the sound barrier. Let me tell you what to watch for. First, notice the deep color of the sky, how much darker it is at 45,000 feet where Tony will start his dive. You are not only far above the clouds, but also above the haze and dust of the lower atmosphere. You are looking at the pure ultraviolet rays of outer space. There's the peel off. Now listen as the sound builds up. Usually, there are two thunderclaps. One when the plane runs away from its sound, and the second when the sound catches up again. Between the two, you are flying faster than the speed of sound, and it is absolutely silent. Now the sound is building up. The sound barrier has been broken. This is the silence of supersonic flight. Now the pullout is being made. Listen to the noise when the sound catches up. Now you folks have just seen some very spectacular flying. But the point I'd like to make to you is this, that as spectacular as it looks, it's not foolhardy, not without purpose. This airplane was built to take that kind of a strain.
I'll say it was, Arthur.
You know, even when you're flying faster than the speed of sound, this business of flying in our air forces is carefully figured out to the last detail. We take nothing but calculated risks. Calculated risks, you know. Our equipment is the very best. It's built to fly. You wouldn't make dives and pullouts like that with a transport plane. It wasn't built to do that. This kind of an airplane was. Why, we were climbing up out of that dive there at the rate of about 45,000 feet a minute for a few seconds. Even our big bombers, the B-52, the B-47s, they fly so fast, and yet they're built to fly, strong, and have all the bugs been worked out of them. So that really, it isn't something spectacular, this business of flying so fast. It's done every day by personnel that's trained very carefully, by men who are competent to train the youngsters coming along. Your son that joins the Air Force or the Naval Air Service, never fear but what he'll get the very best possible instruction, that every precaution will be made to look out for his safety. Sure, there's danger to it. There's danger to crossing this. It takes a special breed of cat to fly these things. This can't be done by any namby-pamby. That's why all the men you know who are pilots are such wonderful young men. You young fellas looking for adventure, looking for real life, something you love every minute of it, you go and see the nearest Air Force recruiting officer, or the nearest naval officer procurement station, or the nearest air station someplace. Talk to them about it. It's a wonderful life. You'll love the years that you spend there, and you'll use the experience all the rest of your days. Join up. We need you. So now let's get back to the man who knows most about where air transportation is going.
Hello, Art.
Well, Rick, we've told the story pretty good up to now, I think. What would you say we can look forward to in the next few years?
Well, Arthur, you've been talking about jets. You know, it won't be long until we'll be flying from New York to Miami in a matter of 2 hours, San Francisco in 5, and to London in 5 to 5.5 hours. And at altitudes from 35,000 feet to 45,000 feet. In fact, we'll be landing and taking off in most any kind of weather.
Well, that's fine. That's wonderful, Rick. Our planes are flying faster all the time. But what are we going to do about this business of getting from the airport to town and from town to the airport? Doggone, sometimes it takes you longer to do that than it does to fly where you're going.
I know. And we're going to be doing something about that too, Arthur. It won't be long until you'll be going to your midtown terminal. There you'll step into a express elevator and be whisked to the top of the building. There a commodious helicopter will be awaiting to take you, baggage and all, and deposit you at the main airport in just a matter of minutes. And not only from downtown, Arthur, we're going to have feeder lines of helicopters coming in from all the surrounding communities. We're going to make flying better and faster. We're going to make flying available to still more people.
Well, Rick, it's been a lot of fun. A rare privilege and a great honor to do this with you. I've learned a lot, and I hope we've done some good.
I'm sure of it, Arthur. Good luck. God bless you always, Captain Godfrey.
Thank you, Rick. Well, it was a real nice trip, kid. Captain Dick Merrill, it was a rare privilege to fly with you today.
Well, Arthur, I couldn't have been with a better captain.
Thank you. Thank you, Gwen and Helen, for a very pleasant trip. And you, Hugh Palmer, the grand flight engineer. Thank you, Al.
Thank you, Captain.
Grand trip. So remember, when you want to fly anywhere in the world, call Eastern Airlines. If one of our planes doesn't go where you want to go, we'll put you on one that does. And I'll be seeing you, be the good Lord willing.
Time and space. The final frontiers. Conquered by man in the age of flight. A symbol of this victory is the Mobile. Fluid, simple, clean. Its smooth motion keynotes the age of flight. The new age brought on in great part by the Lockheed Super Constellation. As the air age advanced, there was a growing need for an airplane that would set the standard for world air travel. The Super Constellation was designed to meet this need. Huge and powerful, yet precise and finely balanced as a jeweled watch. To make a 66-ton machine ride the air as delicately and surely as any bird is no easy job. Here is the dream made real. But between dream and reality, there is a story of men and tools, the best of men and the best of tools. The best of men, designers, engineers, specialists in many fields, pooling their talents to produce a design that would change the travel habits of the world. Researchers, testing known methods and materials, looking for new ones. the mathematician of the new air age, working with miraculous high-speed computers, planners, policymakers, men of courage and vision, the men of the airlines who stood on the threshold of the new air age and saw what was coming, who prescribed what an airplane must do to serve the age, the airplane builders who arranged financing and hired talent and made the design, and in the end said, "Here is your airplane, the best there is." And the steady craftsmanship of thousands of airplane builders, machinists, metal workers, fabricators, electronics and plastic specialists, welders, tool and die men, pattern makers, electricians, inspectors, heavy machine operators, mechanics. 180 separate skills go into the making of the Super Constellation. In the Lockheed Hall of Giants alone, there are $5 million worth of tools. Tools which in a single quick operation can form parts that are lighter yet stronger than parts produced in any other way. An air hammer, which takes a flat sheet of metal and with a mighty blow of its 120-ton fist, smashes the sheet into a complex shape. A massive hydraulic press, largest of its kind in the world, high as a two-story building, weighing over 2.5 million pounds, costing over $1 million, able to exert a force of 8,000 tons on large sheets of metal. The sheet is laid in place. The monster's jaws move together. Metal flows under the incredible pressure. The jaws open, and where a few seconds ago there was only a flat sheet, there is now an intricately shaped part. A stretch press, a giant Hercules that takes into its iron grasp a wide sheet of aluminum, and at the bidding of a skilled operator, pulls the sheet across the face of a die, giving it permanent form. A great new skin mill, pioneer in the latest technique of airplane manufacture. First of its kind in the world, this machine takes a huge billet of aluminum weighing 2 tons and lays it on a traveling bed. A touch on the electronic controls sends high-speed cutters on their way. The cutters work through the solid metal as smoothly as a hot knife through butter. Soon the finished part is ready. A Super Constellation wing section that once was made up of 1,500 separate pieces stitched together with 5,000 rivets. Now a single piece. A profiler, a sophisticated machine used for making high-precision dies. With uncanny skill, it traces a master pattern, carving its exact likeness from a metal block. Tools, large tools and small tools, each with its special function, doing the thing it does best, and each contributing to the building of the airplane. So it goes, drilling, riveting, milling, boring, grinding, cutting, shaping the 132,000 parts that go to make a super constellation. Smaller parts are stitched together, making larger parts, and the larger parts flow into sub-assembly. Soon we have major units, parts we can recognize, barrel sections for the fuselage, a nose section. Know-how and skill have coordinated production of these parts to a tight schedule. They flow almost simultaneously to a rendezvous at an assembly bay. From a vantage point high above the plant floor, a radio phone system controls the cranes which move these huge sections. One after another, carefully timed and in exact sequence, the pieces go to their assigned positions in the assembly bay. The last unit arrives and is lowered into place. The sections are lined up and locked together. And after outfitting and finishing, an entire fuselage is ready to go to the final production line. Assembly lines have been busy everywhere. When the fuselage takes its place on the production line, inner wing sections have been completed and are ready to be mated. The triple tail, distinctive mark of the Super Constellation, has been standing by, ready to move in on schedule. Next, the engines. The powerful 3,300 horsepower turbo compounds, which give the Super Constellation its superlative performance. With the mating of the outer wing, the last major section is joined to the Super Connie. In outward appearance, the airplane is whole and entire, but much remains to be done. Miles and miles of complex wiring must be prepared and installed to make up what might be called the craft's nervous system. It is this system that serves the instruments and controls by which the pilot flies the plane. The flight engineer runs the engines, and the navigator determines course. Passengers' comfort, too, depends on this maze of wiring. It pressurizes the cabin, provides fresh air and a comfortable temperature, and furnishes light. A traveling paint booth gives each Super Constellation the characteristic striping of the airline it will serve. Let's not forget to hang the propellers. As the airplane nears the end of the production line, final inspection takes place. From tail to nose, from top to bottom, men critically examine the ship. There is one standard: perfection. Everything must fit right, everything must work right. This inspection is final only in that it is the last in a long series of production inspections, starting with the time when the airplane was only bits and pieces spread throughout the plant. Yet to come are further inspections before and after flight testing. And at last, we have a thing of power, a thing of beauty. Another Super Constellation ready to take to the world's skyways. Its beauty is more than skin deep. Lockheed retains leading designers to provide space arrangement and decor to suit the tastes of discriminating passengers, to add the touches of smart comfort which make the Super Constellation the distinctive airplane. Thus, beauty and comfort join with speed and power and strength as Super Constellation qualities. Qualities made certain long before the first Super Constellation was built, when prototypes of every part that was to go into the airplane were tortured to destruction to find their ultimate strength, making sure that the craft would be more than strong enough to stand any stress imposed upon it. This philosophy continues down to the present. Hydraulic components go through stiff tests in the Lockheed Functional Test Lab. Here, each and every working part that will go into the Super Constellation is put through its paces. Instruments go through a rigid check at a console which duplicates exactly the environment in which they will have to operate when they are installed in the airplane. All electrical components must likewise measure up. Again, the standard is perfection. There is no room for doubt or error. Because the Super Constellation flies everywhere, units are tested in ovens hotter than the tropics and in ice chambers colder than the Arctic. In aiming at safety, the human equation is also taken care of. The airline pilots, flight engineers, navigators, and maintenance men who will fly the Super Constellation come to the Lockheed School for training. There are constant improvements, new techniques for them to catch up on. These men are already experienced and highly capable, the finest to be had. But these courses help them get the most out of the Super Constellation by making them familiar with new systems. Expert instructors use the latest training devices, charts, and operational mock-ups to make the crew and the plane fully acquainted with each other. By the time the course is ended, the crew knows the airplane. They are fully equipped to take over when it is delivered. The airplane is ready. The crew is ready. They come aboard and take command. A proud ship, a proud crew. A proud mission, serving the travelers of the world. In ever-increasing numbers, these travelers come, attracted by the beauty and comfort, the speed and reliability of the Super Constellation, the world airplane. Whether you're on business or pleasure, this is the way to travel. Relax and enjoy yourself. The airline is dedicated to your service to make things pleasant for you. The luxurious Dreyfus interior is a delight to the eye, the soundproof cabin easy on the ears. Yes, this is the way to travel. Hungry? Just place your order. When you're high over the earth, its beauty spreads before you in a way you've never before seen. Some like scenery, some just like to snooze. Take your choice. Whatever you like, it's there for you. A cocktail, a pleasant game of cards to while away the time, with charming company in beautiful surroundings. Yes, this is the way to do it. This is the choice of travelers the world over. 250 million passenger miles flown each month, 40,000 Atlantic crossings to date. These figures are a testimonial to the Lockheed Super Constellation. From their birthplace in California, they have gone forth to blaze skyways over the entire Earth. Alaska, Canada, the Americas, North, Central, and South. On across the Atlantic to the capitals of Europe, the Mediterranean, Africa and the Near East, India and the Orient, Australia and the vast Pacific. The 7 seas are short hurdles, the continents wayside stops for the Super Constellation. The Super Constellation has annihilated time and distance. Empress of the skies, pioneer and leader in world air travel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.